All right, so here I've got a problem that expresses concentration in two different fashions for one solution, for a given solution, and we're asked to find the density of that solution, okay? So let's read right through it and then see what we're given, and then maybe figure out how we can calculate the density from what we're given, what we can pull out from what we're given. So an aqueous solution of sulfuric acid, H2SO4, has a molar concentration of 8.010 big M and a molality of 6.074 little m. All right. Calculate the density of the solution. So anytime you're given a problem in chemistry, and most specifically in Chem 2, I guess is what I'm speaking to, it's critically important that you understand every word of the problem, what you're asked, and then how maybe you could get to that. So I know that might seem somewhat vague, but as we're reading through, I would specifically go through and say, okay, we have an aqueous solution, so that means we've got a solution. All right, I know it's not solid. All right, of sulfuric acid, and I'm given this chemical formula for it here, right? So that may be significant. Maybe I could use that when I'm going through. I could see this and say, okay, well, I could definitely use a periodic table and find a molecular weight for this compound here. Okay, so let's just keep going. It has a molar. All right, so I know that that's molarity. All right, concentration of 8.010 big M. All right, again, that refers to molarity. The big M does. All right, and then a molality of 6.074 little m. Molality, M-O-L-A-L, molol. Big difference here. All right, we're going to see that. I'm asked to calculate the density of the solution. So now let's maybe define, before we go any further, what the difference between molar and molol is. So let's use our big M. All right, that's going to be molar. All right, and that is going to be defined as mole over liter. Okay, and a lot of people would stop there and say, oh, that's, if I ask someone, say, well, what is molarity? They say, well, it's this mole per liter. And that is mostly correct. However, to be more specific, we would say that's a mole of solute over our liter of solution. Okay, now, what's the difference between molar, big M with an R, molar, all right, molarity, and little m, molol, all right? So on the top, we're going to have mole again. This time on the bottom, we're going to have kilogram. However, there's more difference than just this. It's kind of hard to see that. That says mole, M-O-L. Apparently it's going to be just a little bit fuzzy. I apologize for that, but hopefully I'll explain everything well enough. So again, let's pick back up where we're at. So molol, little m, is going to be our mole of solute. So we see no differences here, not yet. All right, on the bottom, over here we have liters of solution. Now on this side, we've got, this time it's kilogram of solvent. Okay, so back to our original problem. This is an aqueous solution of sulfuric acid. Now, when you see this, most of the time we have to understand that H2O is our solvent, all right, because water is a universal solvent in chemistry, okay? So we now know that kilograms of solvent, this is going to be referring to the mass of the water, all right? On the top, our mole, this is going to be the solute. Our solute is going to be our H2SO4, our sulfuric acid. Okay, likewise over here, the mole of the solute, all right, is going to refer to our H2SO4, all right? And then the liters of solution will be the combination of the sulfuric acid and our water. Now, let's talk about density too. So let's define density. Density is going to equal some mass over some volume. Okay. And for this problem, it would probably be best to just express that in grams per milliliter. However, there's another way to do it that would be acceptable. But if your professor or whoever does not specifically tell you how to express it, you have a few options. Okay, so but this time it's going to be the mass. Let's further define this. Let's say this is the mass of the solution over the volume of a solution, of the solution. Okay. All right. Again, this video is just a little bit fuzzy. However, hopefully you'll be able to understand everything that I'm saying. so that you could kind of make your own corrections possibly to the blurriness. So, all right, now we realize that we're looking for the mass of the total solution over the volume of the total solution here. All right, we see that from our molarity, we have liters of solution. All right, so that would be the solute plus the solvent. So maybe that'd be a good link to get to this volume of the solution that we're looking for. Right? You know, we're looking for milliliters. That's in liters. That's not a big problem. We could deal with that. So let's first maybe find out that we can maybe figure out a mass per liter, which is very similar to our density for molarity. So let's do that. Let's do something called dimensional analysis, and we're going to say that we have 8.010, all right, mole of solute over 1 liter of solution. Okay, you'll see why I'm writing it this way in just a second. All right, and this is dimensional analysis. So if you don't know, anytime you cross that bar this direction, that's multiply. If you cross the bar this direction, that's going to be divide. So this would be 8.010 divided by 1, which is, I got that straight from our molarity. Okay, you need to be able to do this. And if you didn't understand the definition of molarity, you wouldn't know to set it up like this on your dimensional analysis bar. So it's important that you're able to pull things like this out of a problem and further analyze them. So in this case, we're going to take this mole of solute in 1 liter solution, and we're going to take that mole and find out how many grams of solute would be in 1 liter solution. All right. The way for us to do that is to look at our periodic table elements and find what the mass for hydrogen is, sulfur, and oxygen. So then we take whatever the molecular weight of hydrogen, which is 1.008, molecular weight of sulfur, times it by 1. Hydrogen will be multiplied by 2, and then oxygen, 15.999, times 4. And you would add all those together, right? You should be very familiar with to do this if you're even looking at this, watching this video. In which case, I'll just tell you that everything is going to total up to 98.0794, and I'll write that right here. Whoops, excuse me, I hit the camera. All right, so get everything straight. We're going to say 98.07948 grams per mole. All right, I would have got that straight from the periodic table elements. However, I looked up with Google. You won't have that to your advantage on a test. So let's continue further analyzing. So now back to where we're at. This from this dimensional analysis came straight from our molarity up here, okay? And the reason we're using this to begin with is because we've already got mole of solute per liter, and I want to go ahead and get it to grams of solute per liter, all right? You'll see why very shortly, why we want to get to that. You realize that it's going towards our density, but we've still got to find the total solution. But first, let's start by finding just what the mass of the solute in the solution is, okay? So we're going to use our link up here, all right? And I'm going to write it this way, 98.07948 grams are in 1 mole of sulfuric acid, right? So we could say that's a solute, okay? And we'll say grams of solute. All right, so now you would see if you did this correctly that, let me grab another colored pen real quick. All right, you would see that mole of solute here and mole of solute there are going to cancel, right? If you didn't do it right, you would have wound up with this. In this case, it actually would have been mole of solute squared per liter of solution times grams of solution, right? So you'd wind up with these really, really funny units. However, in this case, they just cancel it out fine. So let me grab a calculator and do this right quick. All right, we're going to have 8.010 multiplied by 98.07948. Okay, that's going to total at 785.61663. Okay, and that's going to be, again, grams of solute over liter of solution. Okay, so we're gonna realize that this is going to be part of the final that we put together with something else to get to the density. However, we're going to kind of leave this set for just a second. We're going to come right back to it, okay? Because at this point, I've got my grams of solute in 1 liter of solution. But now I really need to find out, since there's no direct path to figure out what the mass of the solution is, okay, in a given volume, I need to find out, well, I need to find out what the mass of the solvent would be in a given volume. So fortunately for us, we have a link between those two. We have a commonality between these two expressions right here. We see that molar solute and molar solute there, those are both explicitly referring to our sulfuric acid. So we're going to use that to our advantage to maybe relate this solvent, this kilograms of solvent, back to our liters of the solution, and then see if we can put that together over here to get to a final density. So to do that, let's just start with, let's start with our same molarity, all right? And we're going to say 8.010 mole of solute, all right? Okay, over a liter of solution, all right? This is going to be our molarity. Now, we're going to take our molality, the way we had it up here, which is going to be this 6.074 molal, all right, which is going to be our mole of our solute over our kilograms of solvent, and we're going to plug that into this dimensional analysis bar in such a way that our moles of our solute would cancel, right? It would have to be on the bottom if we're going to cancel it out, all right? So what we're going to do is I'm going to go ahead and put it right there. All right, molar solute. This helps a lot of times. Me in particular, I do this so that I stay straight with putting it on the right spot in the dimensional analysis bar, whether it be top or bottom, okay? And then at the top, we're going to have our kilograms of solvent. All right, now let's look at our expression up here. We realize that we have 6.074 mole of solute in an understood 1 kilogram of solvent. Okay, so as we see again, let's swap pens here. Our mole of solute is going to cancel here. All right, and that's going to leave us with kilograms of solvent over our liters of solution. So let's do that right quick. Well, first, yes, let's do that right quick. Okay, so we're going to have 8.010 divided by 6.074. All right, now we have 1.3187. 355. Okay, that ran off the paper just a little bit. That's okay. And of course, I use the big numbers as much as I can just because I don't like to do any intermediate rounding. When we work in things like kinetics and pH and stuff like that, you work on a logarithmic scale. Sometimes rounding can harm your final answer and cause some inaccuracies, but that's okay. For the purpose of this, we're still demonstrating the same thing. And now right here, we need to realize that this is kilograms of solvent per liter of solution. Okay, so now we see that we've got now exactly how many kilograms of a solvent we have in a liter of solution. Okay, but this is in grams and this is in kilograms, so it's not a really big deal, except for that we need to go ahead and convert. So I can do one more dimensional analysis bar here. Let me get our paper set up just a little bit. All right, so let's say we have, you could have continued that other dimensional analysis bar, it's no problem. 1.3187355 kilograms, all right, of solvent, all over 1 liter of solution. Okay, we want to get kilograms to grams, so we're going to put kilograms on the bottom. All right, we're going to say that 1 kilogram is 1,000 grams. All right, and so then again, we'll see, I'll swap pens. kilograms are going to cancel, okay? So then we would have, if you do the math on that, that's going to be, I know it seems ridiculous. I'm going to type in the calculator so I don't make an error as I'm talking to you. 1318.735594. All right. And again, this is going to be grams of our solvent over our liters of solution. Okay. So I'm going to make sure we get another little sheet of paper going on here. All right. So now we can see here from this, all right, and also from this, that we know how many grams of the solute we have in a liter of solution, and we also know how many grams of a solvent we have in a liter solution. Okay, again, I apologize, y'all, for the video not being clear. Supposedly an HD webcam, but their definition of HD and my definition of HD apparently are pretty different. But we have our solute and our solvent. Now, if we add these two masses in grams, then that will give our total mass, which would be technically our mass of our mass of our solution over our volume of solution, right? So mathematically, if we were to add 7.8, excuse me, look at me go ahead and convert, and I'll just scratch that out. 785.61663 grams of solute over 1 liter of solvent, 1 liter of solution. So hard to keep straight when you're talking about it, okay? Excuse me. We're to add those to that in our 1318.735594. This would be grams of solvent over 1 liter of solution. Okay. Solute plus our solvent is really a solution, right? So all this is going to equal, come down here, all right, all that is going to equal, let me add that right quick in the calculator so we have an accurate number. Okay, that's going to give us 2104.352224 grams of solution over 1 liter of solution, right? Now, at this point, we are technically, sorry guys, I didn't realize the video was down where it is. Let's go ahead and get this straightened out just a little bit. All right, so we're pretty much in density now. We've got a mass over a volume, okay? But more commonly, this is going to be expressed, per milliliter, gram per milliliter. Okay, so we could continue with our dimensional analysis trend that we've been on, and let me slide this up and buy a little more room. We could say that 2104.3522224 grams. Again, we understand that that is a solution. However, the solution is technically going to cancel out here, right? It's just to be understood over 1 liter. Okay, now we want liters to cancel, so we're going to put liters on top over here. 1 liter is how many milliliters? It's 1,000 milliliters. Okay, so again, we're going to take a red pen and cancel that out. All right, and when you do that, you're going to take that 2104 over here, your decimal, and divide that by 1,000. You will wind up with 2.10435. We'll stop there, and that's going to be gram per milliliter. All right, this will be our final density, right? So to recap everything, we started with a solution that was expressed in molarity and molality, right? And we used the common link between those two as our moles of solute, and use that to take this kilograms of solvent and relate it to our liters of solution. And we use this mole of solute in the periodic table to relate that to, as a mass over a volume. All right, and then we took and added these two, right? Because we wanted to see our mass of a solution, which would be our solvent plus our solute, okay, over that whole solution to see what our density was, right? So just as I'm recapping, we understood that water was our solvent, right? And we didn't even have to use the periodic table to figure out water, right? Because we were already given kilograms. So at this point, that didn't even matter. So the molecular weight wasn't even a factor. All right, we used our molecular weight for sulfuric acid, all right, to derive how many grams of that sulfuric acid we have in 1 liter solution. Okay, we then took our molarity and our molality, and then this common link of the moles of solute, we use that to cross those two units out to give us our kilograms of solvent over our liters of solution, which wound up at 1.318. Now the problem here was this was kilograms over liters, and we were looking for grams per milliliter, so we need to go ahead and probably transfer that over to grams. So we did our conversion factor of 1,000 grams over 1 kilogram. We crossed out our kilograms here. We wound up with grams per liter. Okay. From that, we took our this is our weight. This is our grams of solute in 1 liter solution. Okay, so this is sulfuric acid. We added that to our grams of solvent, which is our water. We added those two to get the total, which is the solution, right? Which is 2,104.355224 grams of our solution in 1 liter of the solution. So now we're expressing terms of solution over solution in grams per liter. Again, more commonly, this is going to be expressed in grams per milliliter. So we did a quick conversion factor again, and we found out that 1 liter is 1,000 milliliters. So we use that conversion factor across our liters, and now we've got 2.10435 grams per milliliter is our final density, and we got that from using our 2 different concentrations. So everybody, good luck out there, and hopefully this video helps you in some way, shape, form, or fashion. And I may continue to do these in the future. So good luck, everyone.